Hello, my pre-algebra students. This is 2.3, Simplifying Variable Expressions. So we have a couple of vocabulary words to get through. So the first one is terms of an expression. Terms are the parts of an expression that are, sorry about that, that's spell change, are added or subtracted in the expression. And there's other definitions, but I think that this one will suffice. Now, to give you some examples, what do I mean in terms of an expression? All right, so it says the parts of an expression that are added or subtracted. So 2x plus 3y squared minus 6 minus 2z plus 1/2 x. Okay, my terms, I have exactly 1 term, 2 terms, 3 terms, 4 terms, 5 terms. There are 5 terms. And so it's the parts of this expression that are added or subtracted. So there's an addition sign, so a term and a term. Subtraction, so there's a term. Subtraction, so there's a term. Addition, so there's a term. All right? So that's an example for you. So let's look at this one. The coefficient of a term. Let's go back to purple. The coefficient of a term. So the coefficient of a term is, the number associated, and I'll give you examples of this too, with a variable. A variable. Okay? So to give you some examples, 2x, 1/2 y squared, z to the 4th, and x. So these are my coefficients. I see the variable, so it's the number that's associated with that variable. So the 2 is the coefficient, 1/2 is the coefficient. If you don't see a number there, it is understood that it's 1. So a lot of times we don't write it because it adds no value, but there is always a value, a number with a variable. So I know it's 1. And then I have an x here, so my coefficient here would be 1, 2. Okay? So those are examples. Now, constant terms. Constant terms is, there's just no variable. So these are rational numbers. Okay, and I'll give you some examples of that. Rational, and I'm going to abbreviate the word numbers. So basically, there is no variable. There is no variable. Okay, your secret word is camping. So here's some examples. So 3, 1/2, square root of 9, -4, 1.75. So they're constants, there are no variables. All right, so now let's look at like terms. Like terms, these are constants. Constants are like terms. Or, so I should put variable terms and or variable terms. And I'm going to speak more about variable terms because there's actually 2 requirements. These are constants or variable terms that are alike in an expression or equation. Or equation, U-A-T-I-O-N, or equation, okay? So let me talk about these variable terms. And there's 2 requirements in order to be like terms. So I'm going to erase, let me see here. Yeah, I'm going to erase this up top here, if you don't mind. So I got a little bit more room here. so give me the red. So we're going to put 2x squared x 3x squared 4 z 1/2 z squared and 5z. Okay, so let's look at what are like terms when we're talking about variables. Constants are easy because they're just numbers. So let's look at our variable terms. All right, in order for variable terms to be alike, if you will, they have to have the same variable, but then, which in this case, they're both x's, so that meets one requirement. The second requirement is the exponent with that variable has to be the same. So if I look at this 2x to the 2x squared, I see that this has an exponent of 2. If I look at this x right here, I see that exponent is 1. Those exponents are not the same, therefore they are not like terms. So you cannot add or subtract them until you actually know the value of x, okay? So I have, so there's a 2x squared, and there's a 3x squared, so same variable, x, and same exponent, squared, are 2. Therefore, these are like terms. So x stands by itself. There is no other x's. So 4, I see no constant term, so that stands by itself. So here's a z, and there's a z, so variables are the same, exponents are the same, so those are like terms. This actually has a square, so this stands by itself too. 4 stands by itself, and that x stands by itself. Okay, so that's some examples about like terms. So let's see what's next. All right, so we're identifying parts of an expression. So your expression is 5 minus 2x minus 3 plus x. In number 1 here, they tell you to write the expression as a sum. That just means as all addition. So this would be 5 plus negative 2x plus negative 3 plus x, all right? And then if I look at number 2 here, identify the parts of the expression. Note that because x is equal to 1x, and they're talking about this one right here, then the coefficient of x is 1, all right? So here's my terms. My terms would be the 5. My terms would be negative 2x. My other term would be negative 3. And my other term would be x. So I have 4 terms there. So my like terms would be the 5 and the negative 3. Okay. Then you also have the negative 2x, and you also have the x. Those are like terms. So if I look at the coefficients, remember coefficients are just with the variables. So I have my coefficients are negative 2, and my other coefficient is 1. And if I look at the constant terms, that'll be these right here. So that would be 5 and negative 3. All right. So now what I want you to do is I want you to answer this checkpoint right here. So pause the video, answer 1 and 2. Once you have an answer, start the video back up, and we'll check our answers together. All right, so they tell you identify the terms, identify the like terms, the coefficients, and the constant terms. All right, so let's identify the terms. I have 4y as a term, 6 is a term, and 3y is a term. So we got that first part. Like terms would be the 4y and the 3y. Variable is y, exponent is 1, therefore 4y and 3y are like terms. 4y and 3y. Okay, so that takes care of that. The coefficient in this case would be 4 and 3. That takes care of that. And then the constant term in this case is just 6. So my constant term is 6. All right. So now let's look at number 2 here. I have, oh, let me go back. Oh, I'm so sorry. I forgot the subtraction sign. So this is actually your constant term is actually negative 6. All right. So let's go over here. I'm going to rewrite this as a sum. So it's 9 plus w plus negative 5 plus negative 8 w. Okay. So now let's look at, let me get a different color here. How about red? So our terms are 9w, negative 5, and negative 8w. So we took care of that. There's 4 terms. The like terms would be the 9 and negative 5. All right. And then I also have the w, and I have the negative 8w. Okay. Takes care of that. Now if I look at the coefficients, I have 1 and I have negative 8. And then if I look at and that takes care of that piece. And then if I look at the constant terms, it's just the 9 and the 5. Okay. So my constant terms would just be 9 and negative 5. All right, so that answers those two questions. So let's go to the next page. Let's see what we have here. Simplifying the expression. 5m plus 8 minus 3m minus 7. So we're going to rewrite this as sum. So I have 5m plus 8 plus, oops, sorry about that, plus negative 3, negative 3m, I think, right? And then plus a negative 7, all right? And then the next step is commutative property. So what I need to do is to get the like terms together, if you will. So I need to get that negative 3m with the 5m, and I need to get the 8 and the negative 7 together, all right? So all I did was kind of rearrange here. And then the next one is your distributive property, if you want to look at it like this. If you notice, they took m out of that piece, that term and that term, so now I have the 5 plus the negative 3, all right? And I still have the 8, and I still have the negative 7. Now I can go ahead and simplify. And if I look at that 5 plus the negative 3, it would give me 2m. And then if I look at the 8 plus the negative 7, that would be plus 1. So your answer in that case would be 2m plus 1. All right? So let's go on. Simplifying expressions with parentheses. So let's look at A right here. So we have 3 times in parentheses x plus 2 minus x plus 9. So we have 3x plus 6 minus x plus 9. All right, so now we're going to group our like terms together. So we have 3x minus x, and then you have the plus 6 plus 9. All right. Now be very careful when you start grouping terms. Make sure you look, when you start to move a term, make sure you look at the operation that is before that term, because that tells you whether you're adding or subtracting. So now I'm going to combine like terms. That 3x and minus an x would give me 2x. And then 6 plus 9 would give me 15. It is positive, so it would be 2x plus 15. So that's your answer for that, for A. So let's look at B here. I have 2k minus 5 in parentheses k plus 4. So let's do our distributive property. I have 2k minus 5k minus 20. And be very careful right here. When you're doing distributive property, and if you have a subtraction sign, I'm going to rewrite this so maybe this will make more sense. I would have as a sum, so I have 2k plus, this would actually be a negative 5, right, times in parentheses k plus 4, all right? So if I look at this negative 5 and k, that's this piece, right, minus 5k, which is the same thing as negative 5k. And then I have a negative 5 times a 4 would be negative 20. And so if I look at this right here, a positive 20 is the same as adding a negative 20, all right? So now what we're going to do, we're going to combine like terms here. So I have these as like terms, 2k minus 5k, that would be minus 3k, right? And then you have minus 20, right? And so that answers that at letter B. So now we have C. We have 5a minus, in parentheses, 5a minus 7 is equal to 5a minus a 1, 5a minus 7, all right? That's the identity property. So what all they're telling you is that because of that subtraction sign, you're changing the sign of this, and you're going to change the sign of that also. I'm sorry, not that piece, but the 7. You'll change the sign of that. So one way to look at this is there's, because I have a set of parentheses, there is a number right there, if you will, a value before that set of parentheses. If you don't see a number, and then it is understood 1 is understood there. Just like you see this 5 right here, just like you see that 3, there is a number there. If you don't see it, 1 is understood to be there. All right. So now let's just go ahead and distribute. I have 5a minus 5a, right? But then you have this minus 7. So if I look at that, subtracting a 1 and subtracting a 7, when I go to multiply them together, it's actually going to be plus 7. All right. So in case you don't understand that, let's look at that real quick. So I have, I'm going to rewrite this, 5a plus a negative 1 times, in parentheses, 5a minus 7, right? So if I go ahead and do my distributive property, I have 5a plus a negative 1 times 5a, that would be negative 5a, right? And then the negative 1 minus a 7 would be the same thing as plus 7, all right? So that's how I got to this point right here. Now combine like terms, you have 5a minus 5a, well 5a minus 5a, they cancel each other at 0, and all you're left with is just 7, and then obviously 7 in the last one, okay? So it's 5a minus 5a plus 7, all right? So now what I want you to do, you have on this next page, I think sometime today, yeah, there you go. So you have a checkpoint. What I want you to do is to pause the video, run through these 3, 4, 5, and 6. Once you finish with those problems, simplifying the expressions, and then start the video back up, and we'll check our answers, okay? All right, so we're going to look at number 3 first. We need to combine like terms, so the 4y and the 3y. That gives me 7y, and then it's minus 6, so that would be a simplified version. If I look at number 4 here, I have the 9 in that minus 5. I have the w in the minus 8, so I have 9 minus 5 plus w minus 8w. All right, so if I look at that, it's 4, and then it's going to be plus. So if I look at that, that would be a negative 7w, right? Positive w right there, minus 8w right there. Another way to rewrite this would be 4 minus 7w, okay? So now, if I look at number 5, we have to do distributive property first. So 4 times x is 4x. 4 times that 1, so that's minus 4. And then bring the rest of this down, minus 2x, minus 7. So I'm going to rewrite this using the commutative property. So I have 4x minus 2x minus the 4 minus the 7. So if I look at this piece right here, I have 2x. And then if I look at this, this would be minus 11. All right. Another way to write that would be 2x plus negative 11. All right. So now let's look at 6. I got to do distributive property here. So negative 6 times k is negative 6k. Negative 6 times that 3 would be negative 18. Okay. And then bring down the rest of it would be plus 5k. All right. So I have, and let's go ahead and rearrange here, commutative property. Negative 6k and plus 5k and plus negative 18. Then I can add like terms, so that would be negative k plus a negative 18, and or you could say negative k minus 18. Either way would be fine. There, it's correct. So that's the checkpoint. Let's see what's next. Do I have another? That was it. So that concludes your 2.3 video. I think I can go back. No, I can't go back. Yeah, let's go back. All right, so that concludes your 2.3 video. Have an awesome day, and we'll see you tomorrow.